So today we're going to be talking about one of the coolest parts of our tool, and that is generic tables. This was very popular in our SysML v1 tool, and many people are asking questions about SysML v2, what tables look like. I just want to caveat this with the specification is still being worked on for this particular topic. So some of this is subject to change. But we do have a capability of customizing tables in SysML v2 in CATIA Magic 26x hotfix 1. Here we go. So there's a couple of prerequisites. We are going to need basic understanding of the SysML v2 textual notation. Now, why is that? This is just for this initial release. In future releases, this will be a little bit easier. We're going to add some user interfaces that will give you the boilerplate textual notation and things like that. But for now, you will need to understand the textual notation and type this stuff out manually. Additionally, you'll need a basic understanding of the CATIA Magic interface. This will make it a little bit easier. As I was saying before, I just want to caveat with in 26x refresh 1 that we're releasing in July, we have some things that will make your life a little bit easier when it comes to creating these tables. But for now, there's going to be a lot of reliance on the textual notation. Okay, so there's two main different methods. You can reuse existing tables that we have for you, and this means you will be inheriting columns. You'll need to add or remove the columns you don't want and redefine if you want to change certain things to these tables. Additionally, I'll be showing what it's like to create a view definition or usage completely from scratch. Um, and in this case, you would specify all of your columns manually. So we'll see what both of these flavors look like. And then additionally, just note that you could do this with view definitions or usages. But if you want to actually see a table, that's always going to be a usage. The view definition is more of a template to say what goes in that table, but you can't open a view definition. You can only open the view usage to be the actual table. Okay. So we have two predefined tables right now, the generic table, which has these 6 columns here, and then we have the requirements table, which is narrowed down a little bit. It has the name, the requirement ID, and the documentation. Now, just so that you're aware, requirement ID is just the declared short name. This is even written into the specification for requirements. You're just taking the declared short name to be the required ID. Requirement ID. Okay, so if we're going to build from scratch, one of the tables that we have is the base table, and this is going to allow you to create tables from scratch. So what we're going to do is we're going to create a view definition here. We're giving it this short name CRTD, and then the long name is the custom rec table def. And it is going to subclassify. That's what the colon angular bracket means, is subclassification. And then we give it this library path so that we know where the base table resides. If you want more information on each of these slides, you can feel free to click the link. In this video, I will share the PDF of this presentation so that you'll be able to access this. Okay, so the steps are pretty much the same whether you do it from scratch or not until you get to the actual adding or removing, changing columns. But we'll go over it in both cases. So the first step that we're going to be doing is redefining our renderer. Um, um, and so in order to do that, the first thing we want to do is we want to import our different libraries. We have the kernel library. This gives us certain functions. The SysML library, this gives us access to the SysML v2 language concepts. And then DS views, this one is for our tool specifically. This gives you access to like the base table and other things like that. Maybe in the future, if the specification has some sort of base table, this will be moved into the SysML library, so you may not need to use our library here. Additionally, we have the symbolic views by expression. So this gives us access to a view definition that will filter out some of the like um, very generic elements that we don't actually want to see. Okay, and then we want to choose our view definition, create and expose. You can think of the expose as your scope, and then choose our filter. Filters are optional, but it allows you to down select if you only want like requirement usages or part usages, etc. And then once we've done all this, we can redefine our renderer to be as table. So we'll see what that looks like right here. So again, we're calling this from scratch. We have this view usage here, calling rectable, and it is being typed by our CRTD. This was the short name in the previous, and we remember that we used the base table. It was this subclassified the base table, so we are inheriting nothing from that base table. Only the as table property are we inheriting. Then we're going to expose our requirements. So this is just a package in our model that I'll show later on in the video. And then we have this boilerplate here, rendering, and then this redefinition. That's what this colon and these two angular brackets are. When you see this, this means redefinition of as table. So you'll need to do this each time, but this is going to, again, become boilerplate. So it's not something that you really need to remember too much, other than you'll be copying and pasting it quite a bit. Okay. Additionally, if we wanted to start from some pre-existing view, in this case, we're going to change. We're going to have a view definition of CPTD because we're going to create this custom part table definition, and then we're subclassifying a library path, and we're going to be reusing that generic table. And if we remember, it had 6 different columns, so we'll have to hide some of these. Same steps as before, just as I described, and it looks exactly the same, except for, we're using CPTD instead of the other, and we know that this is the generic table. So this will look differently than the other one. The other one would be an empty table, whereas this one will have 6 different columns that will narrow down. And we'll see more of this in the following slides. So let's take a look at what these 6 columns are. So across the top here, we see what this would look like from default. We have these different colors representing each column, and then further shown in the textual notation. To get to this snippet in the tool, we would be going to our generic table, and we can go to definition, and then you would see in our DS libraries the definition of this generic table here. So we can see we get these 6 columns, and we can either go directly to a feature, or we can use an expression, and we'll go into more detail on that in the next slide. But let's just look at a simple example of this declared name. So in the declared name, each column is a view, and we are subsetting in this case because now we're just view, not view definition. So this is a usage. So we're going usage to usage, and so this is called subsetting. So declared name subsets column, and we have to type it by this column by feature, and then we redefine column feature to declared name meta feature. So you don't really need to understand all of this to utilize it. It's a little bit more advanced. We want to try to obfuscate some of this in the future so that you don't need to be an expert in order to know all of this, but let's just take a look. Most of this is boilerplate except for declared name, which will become a little bit more uh, obvious in the future slides. Okay, so as I mentioned, since we're using predefined, we've got our table snippet just as before, and right after the render redefinition here, we're saying view redefine qualified name, and we have a multiplicity of 0. So this is removing that column. Okay, so that's how to remove it. If you want to add columns, again, we have this column by feature. So we can go directly just one step away, one property away. Then we can use this. This is sort of like a simple navigation in our structured expression from SysML v1. And then if you want to do a column by expression, this would be more similar to like the meta chain or a script, something like that. So you can go and do more complex things. Additionally, each cell in this case would represent either, you have to say whether you are wanting it to be a Boolean, element, enumeration, etc. They're all written here. So now let's take a look at what we've changed. So what I have highlighted here is the column that we added. We say, again, we removed that qualified name, and now everything that's highlighted is boilerplate except for type here. Um, so what I'm saying by except for these is type and type here. Remember earlier when I mentioned that other import would give us a specific filter for our view? Well, here we are right here. You'll see this is a comma separated list. That means that view parts table is defined by CPTD and non-standard library element filter. So you can have a comma separated list of definitions for your usages. Okay, and again, that just filters out some library elements that we don't care about. All right. Additionally, if we are building our table from scratch, we have that same boilerplate here. The only thing that we have to do is add in order what columns we want. And again, I'm saying everything's boilerplate except for the view's name and then the feature's name here. And again, we're using, so for this example, declared short name, we're taking away the spaces and we're making the first letter lowercase. Okay, so here we're going to have declared name, declared short name, and type for our custom requirements table. All right, and if we want to do something more complicated, like by expression, now we can see if we ignore all this for a second, we go down to satisfy requirements. We see now we're typing this by the ColumnByExpressionView, and our rendering is now typed by an element cell rendering because we're wanting to accept an element as the cell rendering. Again, most of this is boilerplate. The only thing that's not is this get satisfy, where we're passing in this row element. So we're calling this calculation down here. Now this calculation, it can exist in your column or it could exist somewhere else. As long as you have access to it in this model, this calculation will work for the cell. So our calculation here, we're passing in, we have this Ellie's. This is a name that I just came up with. So we're passing this in and we're expecting it to be part usages. And then we're getting its owned elements. And then we have this select expression. So we're going to select all the elements, and now I'm giving it a different name, reqLEs, that are satisfy requirements. So again, I give it this input. I'm saying the input is expected to be typed by this, and then I give it an actual, I say has type. This is our query here. reqLEs has type satisfy requirement usage. So now what this is going to do is for every element in system structure that is a part usage, we are going to get its own elements, and if one of its owned elements is a satisfy requirement usage, then we are going to return that as the row element here. And since we're accepting an element, we should get all of those elements. So we would be able to see that in our model. One other thing I want to go through here is you see these zeros again, because this is a generic table. This is the CPTD. We used the generic table to build this CPTD, and so we have to remove these three columns. And then I want to declared name, declared short name, and then satisfy requirements. So the order matters here. The order that you specify it here will be the order left to right that it is in the model. All right. Now I have one more cool feature to show, and that is adding the custom view to the menu. So now in this case, okay, we'll come back to this after we actually build out the model. Okay, so let's get out of the slideshow and actually open up this model. Okay, and let's dig around in the model a little bit. So this is the model, and you can see that I have those four imports that we talked about. Notice they're all private imports, and I have a bunch of requirements here. And then we see our requirements definition. So in this case, this custom requirement table right here, this is the one that we built from scratch. So if we open this up, we'll see that we get all of the requirements here, and we get their declared short name, which is their ID, their type, and whether or not they're derived. I added this derived column, but it's not actually being used here. Okay, additionally, we could show the custom view definition here. So if we click over here, we can see again, this is where we remove those three columns, and then we added the declared short name, and we can see the satisfy requirements. Oops. So you see when I clicked on the definition, only the specification came up because the view usage is what is the actual diagram. Okay, so now we have our parts 1, 2, and 3, and we can see that part 1 has a satisfy requirement here. Just as we specified, we get the declared name, declared short name, and then the satisfy. And then additionally documentation, because I didn't remove that. So I ordered this accordingly. We don't have to add or remove columns if they're already there, if we want them. Okay? Only for order's sake. All right, so that's pretty much everything that we just went over and what it actually looks like in the model. So the next step is how can we take these two custom tables and actually be able to come over here and show our custom tables here, like I'm doing right here. So that all lies right here. So before we get into it, I will open it up here, and we can see Okay, so again, everything that is not highlighted in this case is boilerplate. So you create a package. You can name it, whatever you want. And in this case, we're naming it custom view creation dialogues. And then you need a package, this custom tables template. You just need a name for what your templates are going to be. And then you put in the views, your custom views. And then you have to create a part definition for this. So again, custom table creation dialog. Um, and then we are typing it by this boilerplate. This is something that is just really kind of specific to our tool. So I wouldn't say try to memorize it. I would just copy and paste this each time. And then part custom SysML views category, item categories, and then we have these attributes here. First one is collapsed, second one label, and then here we are naming this first category name called SysML v2 custom tables. So when we right click, we will see this as the category name. Okay, and next we'll create this part rec view item, and it's going to additionally have a label that we're going to call custom tables. Additionally, I could have called this CRTD because that's what we're actually creating here. So we'll actually go in and we'll change this. And then we do, the way our R&D set this up is we're going to have a perform action here, and that perform action is going to match our template. So whatever our custom tables template is up here, those will appear in the list. So you'll need a perform action for each one. Okay, so let's go see how this works. So you need to define your package, and then we have a custom tables template here with the view that we want to use, and then here is our part definition. Again, just what I went over before. When we right click, we will see this SysML v2 custom tables here, and in the drop down, we will see the part CRTD. Through this perform action where we're getting the owned element of this package up here. Okay, so if you want to add them, the biggest step is you have to right click on the part definition in the containment window and select Manage Create View Dialog. So you can press this button to bring these back and forth. So we want the custom table creation dialog, and that is the name of our part definition to be selected. And when we do so, here, let's undo it real quick just so that we can see the full process. So let's swap this back over, select save, and when we right click, we see we don't see anything. Then if we go back, and we bring it over, now we see it is there. So we don't have to close out the model or anything. You do need to synchronize the textual notation, and you need to save, and you can do this. So now whenever we want to create another requirement table, say right here, we can do so. And then if we go into the textual notation for that, and we just exposed requirements, for instance, then we refreshed, we see, oh, well, we don't have anything in here. And the reason for that is because we didn't specify this in the actual definition. We changed all of this in our view. So if we wanted to have all of these by default, we would want to come here and copy the filter and then go actually back up to the definition itself. Not there. Um, where is it? Here we are. We'd want to come here and just add all of this in. So now when we add this in, it will become part of our actual view. So we need to remove it from the usage here. Let's just remove it from here as well. Okay. Just removed an old definition I didn't need anymore. Okay, so now when we go to the custom table over here, this is populated again. And so now this table automatically gets populated. And you can see one thing that's not here is this is what I was mentioning to you, like the sub requirements. We didn't filter this out. Originally in our usage, we did some filtering by adding this. Let's see if I can find it here. Yeah, by adding this part right here. So again, if I wanted to take this, I could, I can't make it a definition, but I might be able to instead subclassify and see if it works that way. So here I just added a comma separated list. So I'm subclassifying the base table and this filter. So now when I do this, if I go back here, we can see those elements are removed now. So now if I go here and let's just say I delete this and I create a totally new CRTD. Again, I'm gonna start with a blank table, but if I go to the textual notation, the only thing that I should need to add now is just the expose. Everything else should already be there. So I'm going to expose requirements again. And hopefully this time we'll see that it works. And we do. Okay, so this is hopefully everything that you ever needed to know about building custom requirement tables or other types of tables in SysML v2.